Everyone, in this video I will explain you about the TCP segment. First of all, let's go to a Wireshark and see how the TCP segments actually look like. So I've captured all these packets using the Wireshark, and when I click on any of the packet, you can see that here is the information available about the TCP packet under the TCP transport transmission control protocol, like the source port, destination port, and also having different information about the flags as well. As you can see that the different bits of the flag actually represent different information, like it's saying that the acknowledgement and the push to be one. Push actually means that they don't have to push this in a buffer, and it is just going to push it to get all the data. So we will study about these in detail, and so let's see how an actually packet looks like. So this is the structure of a TCP segment. The first one is the source port and the destination port. The source port identifies the port number of the sending application, while the receiving port identifies the port number of the destination application. The source port and the destination port form a unique identifier for each TCP connection, allowing multiple connection to the same destination IP address. As you can see in the Wireshark, this one has the source port to be this and destination port to be 80, and they both form a TCP connection for transfer of the packet. They both consist of 16 bits, and combined they consist of 32 bits. Next one is the sequence number. Sequence number is the 32-bit field that represent the byte number of the first data outlet in the current segment. It is used to ensure that data is delivered in the correct order and that no segment are lost or duplicated. The next one is the acknowledgement number, which is also a 32-bit that represent the next expected sequence number. It is used to acknowledge the sequence the receipt of the data and to form the sender which segments have been received. The sequence number and acknowledged number allow for reliable transmission of data over the TCP connection. The next one are the flags. The flags are contained within the 6-bit field, and they are also called control flags. The most commonly used flags are REs, the URG, the urgent flag. This flag is used to indicate that the data in the segment is urgent and should be given priority processing. And the next one is the ACK. This flag is used to acknowledge the receipt of the data. When this flag is set, the acknowledgement number field in the TCP header contains the next expected sequence number. The next one is the push. This flag is used to request immediate delivery of the data to the receiving application without waiting for more data to be collected. Next one is the RST, which is actually mean reset, which used to reset the connection. It is typically sent when a connection is no longer valid or has become corrupted. Next one is the SYN, the synchronize, which is used to synchronize sequence number between the sender and the receiver during the establishment of a connection. And the last one is the FIN, which actually means finish, is used to indicate that the sender has no more data to send and wants to close the connection. As you can see, this part is actually unused, and this one is the header length. So next to the flag we have a receive window. A receive window refers to the amount of data that receiver can accept and buffer at any given time. It is essential buffer space in the receiver's memory where incoming data is temporarily stored before being processed. Let's check about this in detail using the Wireshark. Like here is the flag and the next one is the window, and when I click on the flag, as I talked before, that each bit actually represents a different flag, and you can see that the different packet actually has different bits to be one. The different flags are actually enabled and disabled. As you can see that this one is actually having the acknowledgement and the ECN. So let's head over and talk about the internet checkup. It is a simple error detection mechanism used in the internet protocol IP to detect data corruption during transmission. When sending data over a network, the IP protocol calculates a checksum value for each packet that it sends. Next one is the urgent data pointer. It is a feature of the TCP that allow a sender to indicate that certain data within a TCP segment should be treated as urgent. So this one is the option which refers to the additional fields in packet header that are used to provide extended functionality beyond what is defined in the protocol's specification. It can be used to negotiate various features such as maximum segment size, selective acknowledgement, and window scaling. And the last one is the data, which is the payload of the packet that is carried between the source and the destination host. The response from the vessel would then contain the request page contained in the in the data portion of the segment on the response packet. So that is how TCP segment actually look like, and as you can see that here are all the flags and the different and the different segments of the TCP, like the checksum, internal checksum, and the window, the data, and all. So I guess we were able to identify the TCP segment in with more detail. So that's all from our side. Thank you.